Hi, hello everyone. Myself, I am Dr. Varalakshmi, working as a faculty in the Department of Organic Chemistry in Sri Padmavati Mahila Vishwavidyalayam, Tirupati. Now we will discuss the topic reaction mechanism in complexes in coordination compounds. As we know that many of the reactions in inorganic chemistry are ionic in nature. As that takes place almost instantaneously, hence no mechanism is involved in the occurrence. But in the case of coordination compounds, they are slow and they proceed with a definite pathways. The mechanism involved in some of the reactions of coordination compounds usually through substitution reactions and electron transfer reactions. Let us discuss the substitution reactions in octahedral complexes. Substitution reactions, it means that replacement of one ligand with another ligand, simply we can say nucleophilic substitution. Why? Because all the ligands are nucleophiles. But in some cases, central metal ion may get replaced by another metal ion. In such case, the substitution can be named as electrophilic substitution because metal ions are all electrophiles. Let us see the substitution reaction. See, this is the octahedral complex. Substitution of the ligand by results in the formation of the nucleophilic substituted metal complex. This means attacking of the ligand or a displacement of the ligand takes place by means of two different mechanisms. One is unimolecular nucleophilic substitution. Second type of mechanism is bimolecular nucleophilic substitution mechanism. The first we deal with the unimolecular nucleophilic substitution. Otherwise we can say dissociative SN1 mechanism. Here is N1. It represents or denotes unimolecular nucleophilic substitution. According to this mechanism, the complex first it undergoes dissociation, means losing the ligand, and it converts to the while during the loss of the ligand metal complex it exists as phi coordinated complex. We can say the structure of the complex is square pyramidal intermediate complex. To the square pyramidal intermediate complex, if another ligand Y adds to this respective intermediate, results in the formation of the octahedral complex. See the steps involved in the formation of the substitution reaction mechanism. It is the complex we have taken is with the metal and with the ligands, number of ligands are 6. So it is octahedral complex. In the first step, what happens means loss of one of the ligand happens to occur. To this loss of ligand, what the complex formed here it is phi coordinated intermediate complex. To this phi coordinated intermediates complex, attack of another ligand Y takes place with the formation of the new complex. First step is the slow step. Second step is the somewhat faster step. From the chemical kinetics, as we know that reaction rate depends only on the slowest step. Here, slowest step involves only the reaction depends only on the concentration of the one species only. So, if the rate reaction follows first order kinetics, we can say. How the rate we can write means rate of the reaction is equal to K rate constant and concentration of the reactant complex. As the rate depends only on the concentration of the one species, the mechanism is referred to as unimolecular nucleophilic substitution. Otherwise, we can say as in this mechanism includes first step, there is a dissociation step. So, this mechanism also termed as dissociative SN1 mechanism. The second mechanism is bimolecular nucleophilic substitution or associative SN2 mechanism. According to this mechanism, the new ligand first adds onto the complex to form seven-membered or seven-coordinated intermediate complex, which readily undergoes dissociation of the ligand to form the final product. In the first step, there is a association of the ligand takes place, results in the formation of the seven-membered ligands which are bonded to the metal. So it is seven coordinated intermediate complex. Since in this reaction, the rate depends on the first step, as we know it is the slow step. So the rate of the reactions depends upon the concentration of the complex as well as the concentration of the incoming ligand. Hence, the rate law can be expressed as rate equal to K rate constant, concentration of the reacting complex along with the attacking ligand. So, it follows second order kinetics. As the rate of the reaction depends, we said, concentration of the two species. So, it is bimolecular nucleophilic substitution or SN2 mechanism. Since in this mechanism, the incoming ligand first gets associated with the complex to forms the associative SN2 mechanism. During these two cases, SN1, SN2 reactions, there are types of intermediates are there. Let us see in the dissociative SN1 mechanism, first type of intermediate formed here, it is square pyramidal intermediate. During the formation of the square pyramidal intermediate from the octahedral complex, there is only the least disturbance to form the resultant intermediate. Later, with the attack of Y, produce the respective octahedral complex. See, this is the square pyramidal intermediate formed with the loss of ligand X from the respective octahedral complex. Later, with the attack of ligand Y to the respective square pyramidal intermediate, it forms the octahedral structure. The second type of intermediate formed in the SN1 reaction mechanism is trigonal bipyramidal intermediate. The geometry is trigonal bipyramidal geometry. In the second step, the MX bond dissociate. During this dissociation, the remaining Ma5 species, they adjust the bond angles to produce the trigonal bipyramidal intermediate. What the change in the bond angles is second and fourth ligand are changed such that their bond angle is from 180 to 200 degrees centigrade. Results in the formation of the trigonal bipyramidal intermediate, which is then attacked by the nucleophile Y, results in the formation of the product Ma5Y. It is evident that the formation of the trigonal bipyramidal intermediate involves the moment of two metal ligand bonds, whereas no such moment is required for the formation of the square pyramidal intermediate. So, SN1 reactions generally they proceed through the most stable intermediate, which is square pyramidal intermediate, unless a trigonal bipyramidal intermediate is much stabilized by pi bonding, then it becomes the more stable one than the square pyramidal intermediate. SN1 reactions proceeds through a trigonal bipyramidal intermediate if that intermediate is stabilized by pi bonding. If the reactions proceeds through the SN2 mechanism, then there are two types of intermediates. The first type of intermediate is pentagonal bipyramidal intermediate. See, this is the complex, octahedral complex. Nucleophile Y is attached to this octahedron, results in the formation of the pentagonal bipyramidal intermediate with the loss of ligand X. Finally, the final product came. In the formation of the pentagonal bipyramidal intermediate, it requires movement of at least 4 ligands to adjust itself for the attack of the nucleophile Y. During that cases, ligand repulsions occur. These ligand repulsions increases the energy of the pentagonal bipyramidal intermediate because the decrease in the AMA bond angles occur and the electron pairs of the metal ligand bond come closer to each other in this intermediate. So that's why the energy of the pentagonal bipyramidal intermediate is high due to the decrease in the bond angles. The second type of intermediate is formed by means of the nucleophile Y attacks to the middle of the one of the triangular faces of the octahedron. As soon as the Y starts approaching metal, what happens means the ligand which is present initially with the octahedral structures, it adjusts itself, it starts moving the middle of another triangular face so that the octahedral wedge intermediate formed as both the X and Y ligands are in equivalent position. The resultant formation of the intermediate we can say octahedral wedge intermediate. See the structures regarding this. See, initially this is the octahedral structure. Octahedral structure contains the ligand X, one of the ligand X and number of another similar type of ligands are 5. With the approach of the ligand Y, what happens means such that this ligand and X and Y are arranged inside they are to be in the octahedral wedge. Finally, with the octahedral complex which contains only the ligand Y with the loss of ligand X. Here the formation of the octahedral wedge intermediates, it requires only the minimum moment of ligands compared to the pentagonal bipyramidal intermediate. In the case of, as we learned, pentagonal bipyramidal intermediate, ligand repulsions are there, whereas here in this case, there is less such that repulsions occur. So, generally, SN2 reactions preferably they proceed through octahedral wedge intermediate rather than a pentagonal bipyramidal intermediate. Thank you.